Okay, start.
Good evening, everyone. Welcome to the MSAI 500 final project team one presentation. My name is Sai Gautam Bandi.
My name is Pen Wang.
My name is Ali Abdul Hamid.
Today, we are going to present how to detect the diabetes using AI/ML solution for the early intervention. As we know, diabetes is a chronic health condition that affects millions of people globally, significantly impacting their daily lives and increasing the risk of developing other severe health complications as well. Early detection and intervention are critical to managing diabetes and improving patient health outcomes. AI/ML can help in fighting diabetes by analyzing the lifestyle and genetic data, pattern recognition, risk scoring of health profiles, early intervention and prevention, managing diabetes and overall health, just analyzing the economic impact of the diabetes, just in US alone, the total estimated cost of diagnosed diabetes reaches around $412.9 billion in 2022. So Team 1 built a AI/ML predictive model using the CDC Diabetes Health Indicators dataset that can diagnose diabetes for the early intervention. This AI/ML solution can be deployed across the hospitals, pharmacies, and help improve the overall health of individuals and reduce the economic burden on society. A small introduction about our data set. We did source the data set from the UCI machine learning repository. The data set has comprehensive list of all the health indicators related to individuals' lifestyle, genetics, and health conditions. Uh, the initial analysis, we did see the data set is highly imbalanced, approximately 13% positive cases. And the data set has total of 21 features, which you can see on the picture. A part of the exploratory data analysis and the future engineering, we did apply multiple AI/ML techniques and data analysis techniques on the data set to identify the right set of the features for the model training and the validation. We started with the descriptive statistics to analyze the central tendency and variability, moved on to the bivariate and correlation analysis to see how the features are related to the target variable, and we did the multivariate analysis to see the status, identify the multicollinearity among the independent variables as well. And we did the feature engineering as well to identify the right set of the features for the model training and validation. I would like to hand over to Ali for the
Hello, so I will be talking about building the predictive model. So from data to insight, we created an intelligent early warning system using a machine learning algorithm that recognizes health trends in the data to determine the risk of diabetes. In other words, our model studies thousands of real-world health records to identify the patterns that often appear before someone develops diabetes. It's like giving healthcare systems an early signal so that they can take action sooner, long before symptoms become serious. So we took multiple approaches to this. We tested different models from statistical methods to advanced AI techniques to find the most accurate and reliable solution. We didn't just rely on one idea or algorithm. We tested several techniques from traditional statistics to simpler and easy to interpret modern AI models that can capture more complex patterns. The goal wasn't just accuracy, but to make sure our predictions are consistent and fair for every patient. Balancing the data, we addressed the data set imbalance with only 13% diabetic cases to ensure fair and equitable predictions for all groups. That imbalance means most people in the data were healthy. If we didn't correct it, the model would mostly predict no diabetes and miss those who are actually at risk. To fix that, we use balancing methods that give equal weight to both diabetic and non-diabetic cases. Training and testing for performance. We split the data set into training and training sets to validate real-world accuracy on unseen patients. XGB Boost emerged as the top performer with 72% accuracy and strong recall. We wanted to make sure that the model didn't just memorize the data it learned from. By training on one set and testing on another, we simulated real-world conditions as if the model were predicting risks for brand new patients. Our best performer, XGB Boost, correctly identified about 72% of cases and showed strong recall, meaning it catches most of the people who are truly at risk, a key strength for early detection. And now I'll hand it over to Peng.
My name is Pen Wang. Here I report some details for the validation and test results. As shown in this table, we tried 5 different models to predict our healthy conditions. They are XGB booster, logistic regression, voting classifier, MLP classifier, random forest classifier. As you can see, the voting classifier is like a team decision. It combines the results of the best models. It performs nearly as well as the top individuals XGB classifier, and often more reliably. And the recall, which is a key metric, is high, up to 0.74. This means the model are good at catching people with the condition, the positive class. That is critical in health-related tasks. You don't want to miss real cases. But the precision here is relatively low, which is about 32%. Precision tells us how many of the people flagged actually have the condition. So the model does make false alarms, but in medicine, it is safer to check more people than miss true positives. Overall, XGB classifier has the best F1 score, which is a balance of precision and recall. Voting classifier is very close and maybe more reliable by combining model opinions. MLP classifier, which is neutral network, has the highest recall, meaning it catches the most actual cases. Next, please. This slide shows the top predictors of diabetes based on the random forest classifier. They are the gene health. Gene health is the people reporting poor health are more likely at risk, and followed by the BMI. BMI is the body mass index. A higher BMI is a stronger diabetes risk factor, and then is the higher blood pressure, often co-occur with the diabetes. These are identified by the random machine learning model called random forest, which ranks the importance of the import features. So next steps in, for next step, first is to improve minority detection. We can aim to increase precision for detecting diabetes cases class 1, which is a minority class, especially reducing false positive. Second is to add more new features such as family history, glucose test data, or lifestyle metric if it is available. And then we can try to create a simple tool or dashboard that health professionals can use to flag individuals who may need follow-up screening. Thanks.
So back over to me. I will be talking about the business applications and benefits of our model. So targeted interventions identify individuals most at risk so healthcare providers can focus on preventative programs, lifestyle coaching, or early screenings where they'll have the most impact. Personalized health recommendations use the model's predictions to deliver tailored guidance for each person's risk profile, empowering individuals to take proactive steps towards healthier habits. Improve patient outcomes. Early detection allows intervention before complications develop, leading to healthier lives, reducing hospitalizations, and lowering long-term treatment costs. Quantifiable impact. A predictive approach like this can help reduce future healthcare costs by millions, improve preventative programs efficiency, and enhance overall quality of life through timely intervention.